All right, let's get started here. This is the video for 12.2, Arithmetic Sequences and Partial Sums. This one is not as long as our 12.1. Thank goodness, right? Okay, so 12.2, Arithmetic Sequences and Partial Sums. So we looked at partial sums before and we looked at sequences. So what we're going to be doing here is we're going to be looking at a very particular kind of sequence, and we're going to look at, how do we find the sum of the first 5 terms of this type of sequence, the arithmetic sequence? How do we find the sum of the first 100 terms of arithmetic sequences? So early on in 12.1, you'll notice that we weren't asking you to find the sum of the first 100 terms or 50 terms or 20, not even 20 terms, because you'd have to find all those terms and add them all up together. But here we'll be asking you to find the sum of the first 100 terms. And the reason why is because there's going to be a formula. Okay. All right. So, okay. So here, let's start off with a definition of what an arithmetic sequence is. Okay. All right. So, the sequence A1, A2, A3, A4 is an arithmetic sequence if there is a number D such that if you take one of the terms in the sequence, whatever it is, okay, and you subtract the one before it, you know what? Let me write it like that instead. Okay, so if you take any term in the sequence and you subtract the one before it, so if that's the nth term, the one before it, n minus 1, right? Okay, so if you take any term in the sequence and you subtract the one before it, again, that order matters. Okay, you always have to subtract the one before it, not the one after it. Okay, if you take any term in the sequence and you subtract the one before it, uh, you'll get t. So no matter which two you pick. Okay, so pick any number in the sequence, subtract the one before it, you'll get some number d, like maybe 4. Pick another number in the sequence and subtract the one before it, you'll get 4. Subtract another one, you'll get 4. Subtract 2 other ones, you'll get 4. Okay, that's an arithmetic sequence. Okay, where d is the common difference. Okay, so let's take a look at some sequences and let's see if you can determine which ones are arithmetic. Okay, so determine if the sequence is arithmetic. Okay, so let's take a look at this first one. Suppose we have 2, 6, 18, 54. Okay, and then we'll take a look at this one. 3, 23, 43, 63. Okay, all right. So in order for us to check, we want to be able to see if when we pick any number in the sequence and we subtract the one before it, do we always get the same number? Okay, so I'm gonna do this in an organized way. So I'm going to just try 6 minus 2 and see what I get. And I'm going to do 18 minus 6 and I'll see what I get. It's not going to be 4. Okay, so I don't even have to check. Once you see that you're not getting the same number every single time, then that's an example of not an arithmetic sequence. Okay, but if you must check this one, you'll see you don't get 4, you don't get 12. Okay, so you don't even have to check that last one. As soon as they're different, it's not arithmetic. Okay. All right, let's check B. So this one is a no. Okay, so let's check this one. Stay organized. 23 minus 3. 43 minus 23. Ooh, so far it looks like it, but check it, keep checking, because maybe only for those two and then the sequence changes. Okay, so 63 minus 43. Okay, and those are the only numbers we have to go by, so yes. Okay, because we see here all of these numbers are the same. So your common difference in this case is going to be 20. Okay? All right. So the nth term, or the function for an arithmetic sequence. Let's go over that. Okay. So what happens is when you have your sequence, what's happening is because you have that same difference every single time, it's like you have to get to the next term, if you know your first term, right? And you know what that difference is. Let's say it's 3, right? Then all you would do is add 3 to that term. And then you add another set of 3, and then another set of 3. Okay, so whatever your difference is. And then here you would add two more sets of D to your very first term. And then A plus 3Ds, and then A plus 4Ds, and then A plus 5Ds. Okay, and it keeps going. Okay, because to get from here to here, that means you have to add D and you'll get here. You'll add D again and you'll get here. And you'll add D and you'll get here. And you add D again and you'll get here. And you'll add D to get here. That means you added D 1, 2, 3, 4, 5 times just to get to here. Okay? Because remember, to get to the next term, you just add D. To get the next term, you add D. You add D. You add D. So to go from here, you have to add D, add D, add D, add D, add D to get there. And that's a total of 5 Ds. Okay? All right. So that's going to kind of play an important part later on when we start looking for the nth term, the formula, and you're given only very specific terms. Okay, so it turns out that your function, okay, is going to be a1 plus n minus 1 times d. Okay, so this here is going to be your first term. Okay, in the book, for some reason, they don't include that one, and I'm not really sure why they don't. Okay. Okay, so here we know a few things. A1 is your first term. So if you want to be able to write this AN formula, you better know your first term. Okay, and we also know that D is your common difference. Okay, and we also know that to find that, you can take any term and subtract the 1 before it. Okay, that's a little sloppy. Let me rewrite that. So take any term and subtract the 1 before it. And again, the order matters. Okay. So these are the two things that we'll need to write our function. Okay. We'll need the first term and we'll need to know the common difference. Okay, so let's try. Find an expression for the nth term of the arithmetic sequence. So we know it's arithmetic, so I make sure, like on the test, that if it says arithmetic, then you can use all the stuff that we're talking about here. If it doesn't say it's arithmetic, but you can check. Okay, sometimes it won't say it's arithmetic. Okay, so check to see if it is, and then you can use everything that we're using, that we're talking about here. Okay, so find an expression for the nth term of the arithmetic sequence. Four, 7, 10, 13, 16. Okay, so again, to write the nth term, we need these two things. We need A1, that's easy, it's 4. And we need the common difference, D. Okay, 7 minus 4, 3. Okay, pretty easy. Okay, so we know it's this is our formula. AN is A1 plus N minus 1 times D. Okay, so we need this, A1. And we said A1 is 4. And D is, again, you can take any of these terms and subtract which one? The one before it. Okay, so if I pick 13, I have to subtract the one before it. 13 minus 10 is 3. Because subtraction is not commutative. So if you subtract the wrong order, you'll get the wrong sign. Okay, so, and if you get the wrong sign, then the whole formula is off. Okay, so just make sure you subtract the one before it. Okay, and so since we already know it's arithmetic, we don't have to check, oh, 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3. We don't have to do that check. It is already telling us it's arithmetic. So we know that no matter which two you get, you're going to get 3. Okay, so no matter which two you choose to check. All right, so we said D is 3. Okay, let me just do it over here in case. Okay, so D is 3. Okay, so so there's your formula. You can simplify this a little bit more. Okay, distribute the 3, so that becomes 3n minus 3, and then clean this up as well. Okay, so an is equal to, combine your like terms. 4 minus 3 is 1. Okay, so 1 plus 3n, or 3n plus 1. Okay, so just clean it up. Okay, so this one's the easy case. Okay, finding an, you're given your sequence, you know A1, you can get D easily. Okay, so let's take a look at more complicated ones. And these are the ones that you have to really kind of think things through. Okay, find the common difference, D. And the nth term, that's that formula. So your sequence formula, AN. Given that, the third term is 15, and your 21st term is 87. Okay, so this is where it gets tricky. You're not given a sequence of numbers anymore. You're given very specific terms, the third term and the 21st term. Okay, so different ways to do this. You could set up a system of equations and solve it that way. To me, if you just sort of use some logic to develop your equations, you can do it that way. Okay, so remember, to go from the third term to the 21st term, remember you add d, 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 right? So here, let me just write it down. It's kind of far apart, but okay, A3, A4, A5, A6, A7, A8. Okay, so all the way to the 21st term, just in case you can't really see it in your head. And to get from here to there, to get from here to here, you would add d to get to here. And then to get there, you would add d again, right? And then to get to there, you would add d. And then you would add d to get there, there, right? How many d's is that? That was added to get from here all the way to there. Okay. So how many d's added? To get to here. Okay. Well, just 21 minus 3, right? So, well, that's 21 minus 3. That's 18. 18 D's added. Okay. All right. So let's take a look at that. Right here, the third term is 15. The 21st term is 87, right? So if I take that 15th term, that third term 15, right? And I add D 18 times, I should get the 21st term, which is 87. Do you see how I set that up? Okay. So, and the way you set these up is always going to be the same. Okay. So whatever your starting term is, you either added or subtracted D so many times to get to whatever other term you're dealing with. So in this case, we're dealing with the third term, which is 15, and the 21st term, which is 87. And we know to go from 15 to 87, I needed to add D 18 times, right? We figured that out. Okay. And so from here, I can solve for D. Okay. So 18D equals 72. D equals 4. Okay. D is something that I need for my AN formula, right? Remember here? Okay. My AN formula, I need D and I need my first term. Okay. So I found the D. Okay. So I'm going to be using this. Okay. I need my A1 formula. Okay. So let's kind of look back up here. A2, A1. Okay. You could use the exact same logic. Okay. That we did over here. Okay, so over here, we can say how many D's were added. How many D's added? Okay. So we can see that's 2, right? 3 minus 1. We can visually see it, but 3 minus 1, 2. Okay. So 2 D's added. Okay. So A1, we don't know A1, right? We're trying to find it. Plus how many D's? Plus 2 D's will give us the third term. What's the third term? 15. Okay. It looks like we have 2 unknowns, but we know what D is. D is 4. Okay. So A1 plus 2 times 4 equals 15. You really only have one unknown, A1. Okay. So subtract 8 on both sides. So we get 7. Okay. So these are the 2 things we need, A1 and D, to get our AN formula. Okay. So AN is, in case you forgot, I'm just going to write it up here. AN is our first term plus n minus 1 times D. Okay, so we're using that. So AN equals A1, which is 7, plus n minus 1 times D, which is 4. And then we clean this up. Okay, so AN equals 7 plus 4n minus 4. So AN equals 4n plus 3. Okay, so that's how you find the AN formula. Okay, so it might help, I would say, definitely write this part out with whatever they start you with and whatever they have you go to, so that you have kind of a visual aid so you can figure out what you're doing. Okay, and you can list, okay, the third term is 15. This one is 87. This one's unknown. You're always going to need the A1. You can attach that part later. Okay, let's try another one just to make sure. Maybe you try it. Go ahead and try it, and then hit the pause button. Okay, so find the common difference. Find the common difference, D, and the nth term, AN, given that. Okay, given that. Okay, so I'm going to give you the fifth term. Fifth term is 12. And the 18th term. 18th term is negative 1. Okay, so go ahead and set it up. If you get stuck, then just hit the play button. Okay, so go ahead and hit pause and give it a try. Okay, so we are at A5, A6, A7, A8, and we're going all the way up to the 18th term. Okay, I know A5 is 12, A18 is negative 1. Okay, so how many D's were added from here to here? How many D's added? Okay, well, it's 18 minus 5. 18 minus 5, that's 13 D's. Okay, so that means my fifth term plus 13 D's gave me my 18th term. Okay, so A5 is 12 plus 13 D's should give me negative 1. Solve for D. So 13D equals negative 13. D equals negative 1. Okay, so we're going to be using that. All right, now let's get our A1. Let's go back up here. A5, A4, A3, A2, A1. All right, so how many D's here? How many? Oops. Let's spell many correct. Ah, that looks like an N. Ah, darn. Okay. How many D's added? Okay. So from the fifth term to the first term, 5 minus 1, right? 5 minus 1 is 4. So 4 D's added. Okay. So then A1 plus 4 D's gives me A5. A1, I don't know, plus 4D. I do know D, negative 1. I do know A5, 12. Okay, so A1 minus 4 equals 12. A equals 16. A1 equals 16. Okay, so I'm going to be using that. Okay, so again, my formula is AN is A1 plus N minus 1 times D. Okay, so when I come up with my AN formula, it's going to be A1, which is 16, plus N minus 1. It's always N minus 1 times D. Okay, clean that up. AN equals 16 minus N plus 1. AN equals 17 minus N. Okay. All right. Okay, so these are about as complicated as they get. If you're really lost with this method, there's another method I said that uses systems of equations. If you love doing those, give it a go. Just have a look in the book or hit the video explanation on these problems, and you'll see that method. Okay. Okay, so let's take a look at sums, partial sums. Sum of n terms of an arithmetic sequence. Again, make sure if you're using any of these things that it does say that it's an arithmetic sequence. So in the previous section, when you had to find the sum of like the first 7 terms, you actually had to find each individual term and then add them by hand or calculator. Okay, so here they're going to be asking you for the first 100 terms or 50 terms. Okay, so hopefully you do not use, you don't do it by hand and find 100 terms individually. Ugh, what a nightmare that would be. Okay, so we have a nice little formula. The sum, the Sn, the sum of the first n terms, and that equals to n times a1 plus an all over 2. Okay, so there are 2 formulas. Doesn't matter which one you use. Your book gives you 2 formulas. This is one of them. This is the simpler looking one of the 2. And this one will always work. Okay, so if you only memorize this one, you're fine. Okay, so here, let's take a look at a few things here. Okay, so if you're not given A1, okay, well, Okay. You can easily find it by plugging into the AN formula. Okay. So just keep in mind that you can use this formula to find any of the terms. Okay. So if you're missing A1 or if you're missing AN, you can use this one. Okay. And A1 is the first term. That's kind of obvious. Okay. But here, this use of AN, that's basically your last term. Okay. Because here we're taking the sum of a finite number of terms. So AN is going to be your last term. Okay. It's kind of hard to see that because we've been using AN as like maybe the 5th term, maybe the 12th term. Okay. So what you're doing here in this formula for the sum is you're basically doing the first term plus the last term divide by 2, and whatever you get multiplied by n. Okay. So if you're finding the first 50, the sum of the first 50 terms, you're going to add the first term and the 50th term, divide by 2, and then multiply by 50. Okay. All right. So let's take a look. Let's do one or two. Okay. So let's take a look here. Find the sum. Okay. This takes so long I can't see what I'm writing because I'm writing and nothing is showing up. Okay. So find the sum of the arithmetic sequence. Okay, so we know it's arithmetic because it said so. Okay, 2 plus 4 plus 6 plus 102. Okay, so great, we have a formula, right? And our formula says, so we're going to be using the formula. Sn says that, oh, you can take the sum of the sequence and that's just n times your first term plus your last term divided by 2. Okay, great. So let's go ahead and plug these in. We know our first term, right? We know A1 is 2. Our last term, AN, is 102. Okay, so our sum is going to be, I don't know what N is, but I know A1, that's 2. And I know what my last term is, that's 102. Okay, so we have an issue here. Okay, so we don't know N. Okay, we don't know N. Okay, but we know A1. Okay, we know A1 and we know AN. Can you think of a formula that uses A1 and AN together and N? Okay, so here, let me help you out. Okay, so we don't know. Okay, so let's use this. We have this formula, the AN formula, and this AN formula uses A1, N, and D. And we know we should be able to find all of those things. We know AN is 102. We know A1 is 2. N is the thing we're trying to find. And D is easy to find because we already know this is arithmetic. It said so at the beginning of the problem. This is arithmetic, so 4 minus 2 is 2. So I know what D is, right? 6 minus 4 is also 2. Any number that I choose and subtract the 1 before it will be 2. Okay, so now I can solve for n. Okay, 102 equals 2 plus 2n minus 2. 102 equals 2n. And we get 51 equals n. Okay. All right, so going back to our formula. So Sn, so n is 51. So S51, the sum of the first 51 terms is going to equal to 51 times 2 plus 102 divided by 2. Okay, so this is going to be 51, 104 divided by 2. So that's 51 times 52. Scroll. And that's going to be 51 times 52, and that will be 2,652. Okay, so that's how you find the sum. If, yeah, okay, let me see if they have, no, okay. All right, so there you have it. Very formula based here in this section. Then the section after this, 12.3, deals with geometric sequences. So it'll be very similar to this. It's just a different type of sequence, but also will be formula heavy. All right, if you have any questions, make sure you email me. Keep up with the homework. Okay, we have one more test coming up, and then your final exam.